So example 1, we want to find new per unit value for all these power system equipments. So starting with the generator. Okay, so as I mentioned last week, first step is we have to draw the impedance diagram. So to draw the impedance diagram, we start with the generator, and then we have transformer, transmission line, and another transformer. We have this impedance diagram. We have generator, and then we have transformer. We have transmission line. Transmission line also only JX, only X. So we don't have this resistance value. We only have impedance value, XTL, so XT1, XG, and then we have another transformer. Then we have look, this ST2. Okay, so this one generator 1, ST1, ST2, and then bus bar. So this one is hanging like this. This is the circuit for example 1. Okay, you don't have the load, so this circuit is hanging like this lah. Okay, so now we have to calculate SG1, SG new, XT1, XTL transmission line, and XT2 new per unit value. So first step, draw impedance. Second step is find the base voltage. So find the base voltage. Voltages for every region. So like if you look at this example, we have 3 regions. So region number 1. So I call region 1, region 2, and region 3. So every region have different voltage level. So for region 1, we have V base 1. For region 2, we have to calculate V base 2. And for region 3, we have V base 3. So as stated in the question, so 11 kV actually is referring to the generator side. So this is a V base 1. And then this data is S base new. Okay, because to calculate the new per unit values, so and Z per unit new equal to Z per units old times S base new over S base old times V base old over V base new square. And this is the equation to calculate the new per unit values. Okay, so find the base voltage for the second step. Okay, how to calculate the base voltage? Step number 2, find base voltage. We know that V base 1 is equal to 11 kV. This one is given in the question. So we have to find V base 2, V base at region 2. So based on the transformer rating, so we have transformer over here. Transformer rating 132 and 12. So to find voltage on the secondary side, this is primary side, primary of the transformer. This is secondary. Okay, to find the voltage at the secondary side, we use this transformer turn ratio 132 over 12, 132 kV over 12 kV times V base 1. So what V base 1? So V base over here. This one is given 11 kV. 11 kV is given. This one, this value. 11 kV is given. So 11 kV is over here. So what voltage level at V base 2? So we just use the ratio over here to find V base 2. So we get 132 kV voltage level at the secondary side over the voltage level at the primary side of the transformer times V base 1, which is 11 kV. Then we will get 132. So 120, 21.
21, sir.
Times level. So 121 kV. Okay. So this V base 2. Then we have to calculate V base 3. Base 3 equal to, look at the turn ratio, 33 kV over 132 kV. So 33 over 132 kV times V base 2. Why V base 2? Because we want to times the voltage level here. Now we already calculate V base voltage level at this bus bar. Okay, is V base 2. So we have to times V base 2, not V base 1. If V base 1 is over here, it's far away. We cannot times V base 1. Okay, V base 1 is for this bus bar, not this bus bar. This bus bar is V base 2. So we have to times V base 2, which is 33 kV over, 33 kV. 33 or 32? Sorry,
30.3.
33, sorry, 1 kV times 121 kV, 30.25 kV, right? So now we already find the base voltages for every region. This is second step. So any question for this V base?
No, sir.
Okay, good. Okay, good. So for step number 3, we have to calculate new per unit values. So starting with SG lah. Okay, for this case, because of the ratings for this generator, if you look at this rating, it's the same as our new base values. So 60 MVA, same as S base new, 60 MVA. 11 kV also same as 11 kV. So if we calculate new per unit value for SG, we will get the same answer. So SG new, let's say, equal to 0.5 times S base new. This one S base new. S base new is 60. This one is given in question. So S base old. S base also 60 MVA times V base old. So V base old. V base old. So this V base old. All base values. Okay. 11 kV over new base value, which is we already calculate this one, and this one, in this case, this one is given 11 kV, so we just use 11 kV over here, so square. So because of this value is same, so we can cancel it out. This one also same, cancel it out, we will get the same answer, 0.5 per unit for SG and S generator. So 1 for the generator. Second, for generator. Second, for transformer. For the transformer, we use the same technique. We calculate XT1 new equal to XT1 old. XT1 old is this one, this value. Okay, 0.10, that means 0.1. Wait, XT1, 0.1 per unit. So 0.1 per unit times S base new. What is S base new? S base new is the new base power, VA, MVA. Okay, new MVA. So in our case, new MVA is 60 MVA. This S base new. So please remember this one. So 60 MVA, 60 MVA. So what is the S base all? S base all is the rating at the transformer nameplate. So in this case, we have 60. So 60 MVA. And then we have to times V base all. V base all. For the transformer is special because we have two voltage level. On the primary side, we have 12 kV. On the secondary side, this primary, secondary. Secondary side, we have 132 kV. So which one we have to use? Actually, you can use both. If you take a primary side, so you have to divide by the V base 1. If you take on the secondary side, 132 kV, you have to divide by V base 2. Because this is the region, right? Okay, regions. So region 1. If you take 12 kV is under the region 1. So you have to divide by V base 1. So going back to this one. So we just take a primary side, 12 kV. So V base new as what we have calculated just now. This one, V base 1. This one new. So new, and new lah. Okay. So 11 kV. So we just divide by 11 kV. So square. So 0.119, right?
0.12.
119, okay, per unit. So J is 1J. This one also J. Okay, don't forget to put J because this is inductive reactance. Okay, J, and J. So make sure for the engineering student, you have to maintain your 4 decimal places. Okay, so the accuracy of your calculation must be in 4 decimal places. Okay, 1, 2, 3, 4. Okay, so please make sure you use this one because for the per unit system, although we have very small difference between 0. Okay, let's say you say 0.2 and 0.1. This is per unit values. When we convert this value back to the actual value, it will have very significant difference. Okay, that's why we have to make sure we use 4 decimal places in all our calculations. Okay. So xt2. So xt2 new equal to J 0.1 per unit times this one is 60 MVA over 30 MVA times 1. So I just take the primary side 132 kV over V base 2. Okay. 132 kV over V base 2 is 121 kV square. So you will get J 0.238 per unit. Right. So transmission line is quite different because given SDL is equal to 20 ohms. Okay. So as I mentioned earlier, to convert this real value into the per unit value, we have to use Z base. So Z base. How to calculate Z base? Z base equal to V base. So V base 2. Why V base 2? Because V base 2 square over S base. Why V base 2? Because this transmission line is placed in this region, in region 2. Okay, this transmission line is placed under the region 2. So for the region 2, V base is V base 2. So to calculate the Z base, we use V base 2 square over S base new. So V base 2 square is 121 kV square S base new. This one S base new is given in the question, so we just take 60 MVA. So we will get Z base. So 121 13 square over 60 MVA. 244.0167 ohms. Okay. So this equation you must remember lah. This equation. Actually, you can derive this equation. Last week I already show you how to derive this equation. So now we just use this equation. So Z base equal to V base S base. This one V base square. And this equation you have to remember. Okay. So we have the Z base. So how to convert this transmission line this actual value into per unit. So XTL per unit equal to XTL actual over Z base. So 20 ohm over 244.0167 ohms. So we will get J 0.0819 96 0 J 0.0x82 lah, okay, per unit. Okay, so this S per unit for the transmission line. So now we are solving this first example. Okay. Now we find all the per unit values for this example 1. Okay. So any question for example 1?
No,
No.
sir. Understand.
No. Okay.
Okay.
All right. So example 2. So a simple power system consists of one synchronous generator and one synchronous motor. Is connected by two transformers and a transmission line is shown in this figure. Okay. So create a phase per unit equivalent circuit for this power system using a base apparent power of 100 MVA. So this S base new. Okay. 100 MVA and a baseline voltage at the generator G1 of 13.8 kV. So this one. Okay. So this V base 1. Okay. So what we have to do? What is the first step?
Change to impedance.
Draw the
Impedance diagram.
So please draw the impedance diagram for this circuit. We have generator, transformer, transmission line, another transformer, and motor. So this circuit breaker. We just ignore this one. So we have this one. Okay. We have resistance value, inductive reactance, generator, and we have transformer, one, transmission line. We have another transformer, generator, transformer, transmission line, transformer, and motor. So we have motor. Okay, this is all the elements in this single line diagram. Okay, so we just reconnect the circuit. Just connect, make a connection between each elements, and then finally we just add the neutral line to complete the circuit. Okay. Now the circuit is complete. This one is ZG. This one ZT1. Z transmission line, and Z impedance of T2. This one Z motor. Okay. Which is Z equal to R plus JX lah. Okay. This impedance. So second step, we have to find the base voltage. Okay. So if you look at this single line diagram, we have to state the region. So if you look at this, the region is already stated. So we have region 1, region 1. And then we have region 2. And we have region 3. We have 3 regions. So we have to calculate new base voltage for each region. Region 1, starting from V base 1. So V base 1, we have 13.8 kV. This one is given in question. Okay. Okay, so we have to calculate V base 2. V base at region 2 based on the transformer ratings. Okay. So based on the transformer rating, this transformer rating, we have 110 kV over 13.8 kV. So we have 110 kV over 13.8 kV times V base 1. This one V base 1. So V base 1 is equal to 13.8 kV. So we have 110 kV. Okay, that's for V base 2. Then we have to calculate V base 3, V base at region 3. So V base at this region. Okay. So based on V base 2, so we already calculate V base 2. This one, V base 1 is given. It's given. This one is given. So V base 2, we already calculate. We got 110 kV. So we have to calculate V base 3 over here at region 3. So based on these transformer ratings, 14.4 over 120 kV, 14.4 kV over 120 kV times V base 2. V base at region 2 is 110 kV. So we will get 13.2 kV, right? 13.2 kV.
Yes, sir.
Right. So now we're solving the V base 1, V base 2, and V base 3. Okay, now we move to the third step. Third step, we calculate the per unit value starting from the generator. This one. If you look at these values, okay, R for generator and X for generator, this one all in per units. Okay, all in per units. But this per unit value referring to its rating. This one refer to hundreds. This one refer to 100. This one refer to 50 MVA. And then this one for the motor referring to 50 MVA. So we have to find the new per unit values for all the parameters. So new per unit value referring to the same base, which is 100 MVA. So we want to refer to the same base so that we can do the analysis generator. So we have Z generator equal to, so Z generator new. So Z generator old, this one Z per unit new lah. Z generator per unit new. New equal to Z generator per unit old times S base new, S base old times V base old over V base new square. Okay. So Z old 0.1 per unit plus J 0.9. So 0. Per unit times S base new. S base new is 100 MVA. This one is given in the question, 100 MVA. S base old, this one at the generator nameplate. So generator nameplate, this one 100. In this case, we also have 100 MVA. So this one 100 MVA times V base old. So V base old, so 13.8. V base new also 13.8. And this one V base new. It's new, so 13.8. So we just put 13.8 kV. and then square. We can cancel it out. We will get the same answer, 0.1 plus J 0.9 per unit. For the generator, we will have the same magnitudes because the generator data is same as the new base. So this generator base, the old base, is same as the new base. So in this case, I just want to show you. So we just calculate this value and then we get the same value lah. Xt1 is equal to, so this one, X. Transformer also, we have R plus XT. So transformer also Z transformer. So this one Z. So we just use this Z T1 per unit new equal to Z T1 per unit old. Z T1 per unit old is equal to 0.01, 0.05, 0.01 plus J 0.05 times S base new. This is given in question, MVA, 100 MVA, S base old, and this one stated on the transformer data, this one. A also 100. Okay. So we will just put 100 over here times voltage V base old. So V base old in this case, we take the primary side, we're referring to the primary side 13.8. So 13.8 kV. So V base 1 also 13.8 square. We can also cancel out this value. We will get the same answer, 0.01 plus J 0.05 per unit. Okay. So for transformer ZT1, we will get the same value. So ZT2 per unit new equal to ZT2 per unit old. This one is old value. Transformer 2, old value 0.01 plus J 0.05. So 0.01 plus J 0.05 times 100 MVA over, in this case, what is the value for MVA base, old base, S base for this transformer?
50.
50, right? So 50.
Yeah.
So 50. Yes, correct. 50 MVA. For the voltage, so we times voltage. Which one you want to refer? Primary or secondary?
Primary.
So primary. Okay. Also you can also use a secondary lah. So if we use primary 120. So 120 kV. So over which V base? We have
100. VB2.
So VB
2.
okay, 110. Yes, correct. Okay. So we have finished calculate for the transformer. What else? We have transmission line and the motor. So for the transmission line, first we have to calculate the Z base, as I mentioned in the previous example, example 1. So Z base equal to V base square over S base new. So this V base, which V base we have to take? We have to
2.
V base 2. Okay, V base 2. Why? Because this transmission line is
Region 2.
in the region 2. Yes, in the region 2. So we use V base 2. So V base 2 is 110 kV square over S base new. What is the value for S base new?
100.
So 100 MVA. So don't think too much because this one is given in the question. Okay, we just use the same V base new over and over again. This S base new 100, just use this value. Okay, 100 MVA. Now we have to convert the transmission line data into the per unit value. This one is in ohms, actual value. We have to convert actual into the per unit lah. ZTL per unit equal to ZTL actual over Z base. So actual is 1575. 15 plus J75 ohms okay, over 121 ohms. So we will get for the motor. For the motor, we have to calculate Z motor per unit new equal to Z motor per unit old. Z motor 0.1, 1.1, 0.1 plus J 1.1. So times this one always 100 VA as mentioned in the question. So the motor ratings is equal to this one motor ratings 50 okay, times the voltage rating for the motor. This voltage rating for the motor V base all 13.8 kV. So V base new. V base new is
30.2.
30.2. This one 30.2 kV. This one 0.21
218.
6 186 plus J
J is 2.398.
2 point huh
2.4045.
045 okay per units. Already calculate all the parameters. We have to write all the values in this circuit. Okay, let's say for the generator we have 0.1, 0.1, J0S 0.9 and so on lah. Okay. 0.01 J 0.09 0.05 and so on. Okay, that's how we solve this question example number 2. Okay, any question?
Sir,
Yes.
contoh kalau jawapan kita macam ada beza 0.00 something tu kira salah ke?
Tak salah tepat, cuma nanti dia akan salah. sebab tu saya cakap mungkin dalam per unit ni tak salah, tak jauh beza, tapi bila you convert to the actual value, okay, let's say we have 100 okay, okay 100 kV okay, no Z base just now Z base 2 we have 121 ohms okay. So this is per unit. Let's say Z transmission line. This one 0.124 per unit, right? Resistance value. Okay. If we want to convert, we want to calculate Z T L actual. ZTL actual equal to ZTL per unit new times Z base. So based on this equation, so we know that Z per unit equals to Z actual over Z base. We rearrange this equation. Let's say this equation 1, we rearrange this equation, then we will get this equation 2. So ZTL actual, ZTL per unit times Z base. Okay, let's say your ZTL is equal to 0.12, not 0.124. Okay, equal to 0.12. So you times this one. So Z actual 0.12 times 121 equal to 1 times
14.52.
14.52 ohms as compared to 0.124. Okay, ZTL1. Let's say ZTL2. So 0.124 times 121. 15. So you will get 15.004 ohms. Can you see the difference? Right.
Yeah.
So in terms of per units, maybe you look very similar, almost same values. But when we convert it back to the actual values, you will get very different, very significant difference between these two values. Because in this power system analysis, and let's say this one, we want to calculate the voltage. This voltage is the real voltage, V in terms of kV. So how many kV? This internal EMF, this one also V. Sometimes we want to calculate current, how many kilo amperes. So when we convert the per unit value back to the actual value, we will get very significant difference between both values. The actual values with 4 decimal places, let's say this one, with only as compared to the 2 decimal places or 3 decimal places. That's why I always stress to my student that we use 4 decimal places in our calculation. Okay.